Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy, and I'm Jeetendra Dixit. So this is another session today. In this session we'll continue AOD. So let me give you in my introduction again in short. So I'm Jeetendra Dixit. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. Today we are going to do AOD. We'll continue AOD basically. I've already taken a few sessions on tangent and normal, and we are doing Rolle's theorem basically. So we're doing Rolle's theorem now. Yeah, Raghav, let's start. You got, you can see me now? So this plus subscription, dates and iconic subscription, 2 subscriptions you can buy. So I've already given you the information. Now let's begin the session today. So we were doing Rolle's theorem, huh? Do you remember that? I gave you some questions in the end. Now I'll give you very good questions of Rolle's theorem today again, and then we'll do LMVT. So let's start with the sum. After this, I'll give you, see, if f is a continuous and differentiable function, okay, and f of A is equal to f of B, all right. थोड़ा छोटा सेशन रखिएगा आज, दो सेशंस हो जाएंगे एंड बायोमोलिक्यूल्स जैसे, ओके ठीक है, ऑलराइट. F of A is equal to f of B is equal, okay, that's it. Then which of the following will be true? We'll finish Rolle's theorem first of all. Then which of the following, because Rolle's theorem has a very important role in JEE main and exam, advanced, basically in advanced. Which of the following might be true? Okay, the first option is F into C into G dash into C plus G into C to F dash into C is equal to 0, where C belongs to for all the options A to B, okay. In this option where G is a differentiable function, Second option is and one more thing I need to add, that A and B are more than 0, okay. So now my second option is F dash, sorry, all right. So 2 times of f of C plus C into f dash C is equal to 0, right? You need to figure out the options. Third, f of C minus f dash C is equal to 0 for some C belonging to C is same, A to B. Fourth option is f of c minus plus 100 times of f dash of c is equal to 0. Oh. Then we have option f of c plus, let me finish the options. I'm going to give you a lot of options. F of c plus c times of f dash a. Wait a minute. Let me do some corrections here. Not the correction, but I'm just changing the question. All right. And sixth one, last one. This is last, okay? F dash c plus minus. So which of the following will be correct? Okay. Now see what you need to do. If f is a continuous and differentiable function and f of a is equal to f of b, then f dash c is equal to 0 for some c belonging to a to b. Now, in all these options, you need to observe that whose derivative is given to you, and is Rolle's theorem applicable to that function whose derivative is given 0? That is what you need to check. I hope you are understanding this. Okay, then try to figure it out. One to pakka hai, right? One is right. Hi, Parshva. 1, 2, and 5 you got, huh? 1 to 5. So 1, whose derivative is 1, by the way? Whose derivative is 1? In this? Tell me. If you take hx is equal to what? Tell me hx for this. Yes, very nice. F into G. बिल्कुल सही है. F into G, and because f of A into f of B is equal to I'm sorry, I need to give this 0, okay? This should be given 0. F of A is equal to f of B is equal to 0. A and B are the roots, okay? A and B are the roots. Otherwise, otherwise rules will not be applicable. Because if f of A is 0, then f into G will also be 0, right? So A and B are basically roots. I forgot to mention it here. It was in my mind, but I forgot to write this. I forgot to write this, huh? Got it? So now you can say h of A is equal to h of B is equal to 0. Now Rolle's theorem is applicable for hx function, and Rolle's theorem is applicable, so derivative of it, this is nothing but h dash is equal to 0. So true. Now in second you are saying 2CF, 2CF. No, no, no. 2CF is not the function. In this HX, what is HX? You need to figure out. This is derivative of something, but slightly tricky, huh? Then in the end, I'll tell you one method to find whose derivative is this. One proper method. Okay. I mean, you don't need to guess in all such questions. If you apply that method, you'll get to know what is HX. But I want you to put some brain before learn that method, huh? Before I tell you that method. Think second. Second is not right. If you differentiate 2CF, it won't be this 2 into F, okay. But if you differentiate 2C, then it is going to be 2CF dash. Then 2 is not there, huh? एक को कांस्टेंट रख के दूसरे को इंटीग्रेट, नो नो नो, दैट इज नॉट द मेथड. पहले तुम सेकंड वाले का आंसर, सेकंड वाले का HX बताओ मुझे. व्हाट इज HX इन सेकंड, देन आई विल टेल यू द मेथड. Parshu, are you doing it? How to do inorganic? Even I left inorganic when I was preparing. I did everything except inorganic. I did inorganic of, I mean, few things like coordination compound and all, but left most of it. But I'm not suggesting that to you. That was not a good that was not a good choice at that time, because in my paper there was a lot of inorganic chemistry, and because of that my marks were less. I mean, I did not do inorganic while I was preparing for IIT-JEE, but that was a wrong decision. I should have. Actually, I was not taught. Nobody taught me. Okay, chalo. Subhash has given the right answer, C square F. Yes. So this is X square F basically. C square he has written. Yeah. X square F function. If you differentiate it, then H dash is going to be 2CF plus C square F dash. That will be 0, and because C is not 0, C lies in the interval A to B, so you can divide by C. So after dividing by C, you will get 2F plus C into F dash is equal to 0. This is given, right? Why not valid? It is valid, huh? See, this X square F is completely differentiable function, and Rolle's theorem is applicable for this. X square is a differentiable function, Fx is a differentiable function. Why not possible? What is not possible? What are you writing, Raghav? Twist, huh? C you needed to multiply. C you needed to multiply. Now, can somebody guess this function whose derivative is this? This is seriously very, very interesting. Now, if you can guess this, then maybe you can do others also, other questions. Okay, let's stop guessing. Okay, I'll tell you the method. So if it is given that F dash X plus Gx into Fx. Okay, now listen to this carefully. And you need to make exact derivative. Acha, okay. Alright. Okay, then try. It's very interesting, by the way. Then I'll tell you the method, and then it is like, oh, so simple. But that method, no, not everyone know that. I mean, it is not known to everyone, that particular method. Okay, try the third one. Try the third one. If you can try third one, then certainly you can solve fourth also. X 100 FC, no. Uh, no, 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 no. CFC is not. Okay, now I'll tell you. Okay, by the way, this one. Okay, let me. This one is basically if you multiply e raised to minus c, you can multiply because e raised to minus c is not zero. Now this is the function e raised to minus x into fx. If you differentiate, e raised to minus x will remain same. This is your hx. So if you write h dash x, that is going to be e raised to minus x f dash x minus e raised to minus x into f is equal to 0. Now you can divide by e raised to minus x, so you can write f dash x minus fx. You can divide by e raised to minus x because that is not 0. अच्छा था. All right, now now you can try the fourth one. Okay, fourth one. Okay, now you can answer fourth one. The similar way you can do fourth and fifth and sixth also. Yeah, e raised to 100x fx. Very nice, very nice. Now you cracked it. The next one. E raised to minus cx. No, that is not right. C should not be there. C should not be there. No, e raised to minus c. C to we will put in place of x. C we are going to put in place of x in the end because the h dash C will make 0, right? H dash C. I'll tell you the method, okay? Now let me tell you the method. See, if this is the function and you need to find whose derivative is this, then you'll have to multiply to make it exact derivative of some function. You'll have to multiply it by some function. See, have a look at this properly. What is this written? In short, you can say it is f dash plus some other function of x into f. Okay, this. So to make it exact derivative, to make this exact derivative, we will have to multiply it by integrating factor. Okay, you know, if you have done differential equation, then you know integrating factor. Okay, that's what is written here, right? Dy by dx plus fx into y. Okay, you know, do you remember integrating factor? So integrating factor is e raised to integration of this function gx dx. If you multiply it by this, then it is going to be e raised to integral of gx dx into f dash plus gx into e raised to integral of gx dx into f, right? Now this is your h dash. And what is your hx? Hx is your e raised to integral of gx dx into f function. If you differentiate it, you will get this. And e raised to integral of gx dx you can take common, and because in equations right side it is 0, so you can divide by e raised to integral of gx dx. तो ये करना है अपन को एंड विल गेट दी, देखो कितने जल्दी मिल जाएंगे सारे के सारे. सो अब इस मेथड से करते हैं, ठीक है? Let's use this method. Remove all these solutions. Okay. Although first wala is very obvious, so we'll leave first one. We can use this method also in any question, any such question where you see f plus f dash with some other function in product. चलो एक एक करके try करते हैं. Let's see this one. Okay. So first write this equation in the form of f dash plus 2 upon c divide by this c. Okay, c is not 0. Remember that. C lies in this interval, so you can divide by c. 2 by c into f of c. So into f we have written, okay, is equal to 0. We need to take. So first integrating factor of this is going to be integrating factor e raised to integral of 2 upon c dx. 2 upon x. So c की जगह पे x लिख लो सब जगह, okay? सब जगह x लिख लो, yes है. So x dx. So if you integrate it, it is going to be e raised to 2 ln x, and e raised to 2 ln x is e raised to ln x square, and e raised to ln x is x, so it is going to be x square. तो हमें मिल गया कि this function, इसको अगर हम मल्टीप्लाई करते हैं, किससे मल्टीप्लाई करते हैं? x स्क्वायर से. तो x स्क्वायर से मल्टीप्लाई कर सकते हैं because x is not 0. So it is going to be x square f dash plus 2x fx. Integrating factor say we need to multiply. Now after multiplying by integrating factor, this will become this is your h dash x, and hx is basically x square fx. We have got x square, right? Itna easy, yeah. If you know that trick, I mean if you know how to solve it, then it is so easy. Not for everyone, huh? Now the second one was f dash x, c को x लिख लो, minus f of x, okay, is equal to 0. Now what is the integrating factor? So integrating factor is e raised to integral of, now you can see it is minus 1. Coefficient of fx is minus 1. So minus 1 dx, which is e raised to minus x, huh? So e raised to minus x से multiply कर दो, e raised to minus x, e raised to minus x. Now this is your h dash x. Hx is going to be e raised to minus x fx. Okay, we'll apply Rolle's theorem in this. Got it? Now the third one. In this third one, what is this? Third one is f dash x plus 100 fx is equal to 0. What is the integrating factor of this? E raised to integral of 100 dx, that is e raised to 100x. So we need to multiply it by, so h dash x is going to be multiplied by e raised to 100x. And you can always multiply by e raised to anything because that's a positive number. So you can multiply positive and non-zero number. So you can multiply by a non-zero number. Huh? So it is going to be e raised to 100x f dash plus 100 e raised to 100x fx. Okay. So what is your hx? And hx is going to be e raised to 100x fx. Okay. So this is the function in which you need to apply. Sab mein valid hai. In all the questions it is valid. You just make the function. And see Rolle's theorem is applicable or not. So because I have applied this condition that c is positive. So because c is positive, so even if you get 1 upon c, then it will be all right. जितने भी देखो जो भी functions में बना रहा हूँ ना hx functions, you can observe that all these functions are differentiable functions. So first you make it and then you come to know, like in this, what is going to be your hx. If you integrate, this is coming out to be, इसको देखो, if you this is x, okay, this is x. So if you find the integrating factor of this equation, f dash x plus c means x fx. Okay, this one, let's see this example. So integrating factor is e raised to integral of x dx, that is e raised to x square by 2. Okay, so now this is the function. Hx is going to be e raised to x square by 2 into fx. So if you differentiate, h dash x is going to be e raised to x square by 2 f dash x plus x fx is equal to 0. You can divide by this and this is given 0, right? This thing. So this is a completely differentiable functions. Parsha, what kind of doubts are you asking? Huh? Parsha Patil. Let's stick to our maths. Huh? How to eliminate competition in JEE? How can you eliminate competition? Huh? No, it's all right, but I don't know how to answer these questions. Which is the best college for aerospace? Aerospace के लिए best college is basically, ऐसे specifically aerospace के लिए I don't know, but in IIT Kanpur, in my college, IIT Kanpur was also there. There was one branch aerospace, and it was quite good because there were gliding club also. Gliders were there. Students used to make gliders, huh? So it was a very good branch with all the facilities available in my campus, IIT Kanpur. Similarly, in other colleges also you'll get that, in other IITs or. Okay, so you got that method, huh? Now I'll give you one more. Huh? If fx is a differentiable function. Okay, let me test first. जो अभी सिखाया पहले टेस्ट कर लें. Okay, इसी में कर लेते हैं. उसी का एक और एग्जांपल दे रहा हूँ, ठीक है? Same conditions. F is a continuous and differentiable function. F of a is equal to f of b is equal to 0, and f of a is equal to f of b is equal to 0, and a and b are positive numbers, and c belongs to a to b. Then you need to answer this whether it is true or not. Okay. X fx plus ln of ln of x fx is equal to 0 for some x belonging to a to b, Try this one. Tell me, Raghav. All right. Take your time. E raised to ln. It is ln 2x or ln square x? I'm not understanding it. Ln 2x. If it is ln 2x, then write 1. If it is ln square x, then write 2. Wait, what have you what? Ln square. Okay. Yes, well done. You have learned it. Good. You have learned the method, huh? So your hx is e raised to ln x the whole square into fx. Okay, this is the function, and we can see that a and b are positive. So this interval where we are applying the Rolle's theorem function is x is positive, right? X is positive. Okay, x belongs to a to b. X belongs to a to b. Okay, so in this function, in this interval, Rolle's theorem is applicable, and this is completely differentiable function, because it might have problem when x is negative. Okay, so x is not negative in this because log x is involved. So perfectly fine. Rolle's theorem is applicable. Rolle's is applicable, and then you can write h dash x is equal to 0, and by putting that you can write x f dash after dividing e raised to ln x whole square. You'll get this e x f dash plus ln x fx is equal to 0 for some x belonging to a to b, or you can take some c belonging to a to b. Or simplify means what? Or simplify. You need to figure out hx first of all. So you have got hx, huh? See, you can multiply this whole equation by e raised to ln of x square, right? You can multiply by this ln of x square. Because it's a positive number, non-zero number, huh? 2 भी था मतलब 2 मतलब I'm not getting 2. Where is 2? Which 2? Thank you, Pallab. Which 2 are division by 2? Division by 2. Where is 2? I mean, in its derivative, are you getting 2? No, we will not get 2. See, let's differentiate it. Huh? Okay, I'll solve it. I don't know, you are getting some, you have some confusion, so I'll solve it completely. Huh? This was given, okay? This was given. There's no 2. See, first of all, I'll write like this, f dash. To know whose derivative is this, I'll write like this, f dash plus ln x divided by x into fx, okay, is equal to 0. Then I'll find integrating factor. To find integrating factor, I'll write e raised to this function, which is coefficient of fx. It is ln x divided by x, integration of this dx. integrate this, you can see ln x. If I put ln x is equal to t x 1 upon x dx will be dt. So it is f into f dash dx लिखा है, तो उसका डेरिवेटिव क्या हो जाएगा, एंटी डेरिवेटिव, इसका इंटीग्रल क्या हो जाएगा, ln x the whole square by 2. Okay, this thing. Now you have got integrating factor, so we'll multiply this equation, this original equation, by this function. So it will be e raised to, okay, by 2. Okay, this 2 you were talking about. All right, I forgot to write that. Yes, you were right. So it is x e raised to ln x the whole square by 2. Yes, by 2 will be there, f dash x, and plus e raised to ln x the whole square by 2 ln x fx, okay, is equal to 0. We have multiplied this whole equation by this integrating factor, and we can write this is nothing but derivative of e raised to ln x the whole square by 2 into fx. Okay, right. So we have taken hx is equal to this function e raised to ln x the whole square by 2 into fx, and Rolle's theorem is applicable to this function. So its derivative, which is h dash, will be 0. अब उल्टा चलते हैं. So we can write this is equal to 0, and when this is equal to 0, so after dividing by this common factor, integrating factor, e raised to ln whole square by 2, because it's non-zero numbers, you can divide by this. You will get to, we'll reach to this equation. Okay, so yes, we can write like this. I got your point. You were talking about that too, which I missed actually. Yeah. अभी ठीक है? No, that was calculation error, because I haven't solved completely that time, so मुझे वो 2 का ध्यान नहीं रहा. What do you want to simplify actually? I'm not understanding. What do you want to simplify? See, we need to find a function whose derivative will give us this number, this function. Okay, but this is not the exact derivative. You'll have to multiply it by something. What was that? That was integrating factor. Okay, so you have identified the integrating factor, then you have multiplied it by that. After multiplying it by that, you have got a function, this function hx. Okay, now you know that if I differentiate h, then I might get the given equation. Okay, if I put h dash x is equal to 0. But to put h dash x is equal to 0, you first will have to see that whether Rolle's theorem is applicable to this function or not. But I'm not understanding your doubt. You're saying that not for Rolle's theorem, but for some other. Not for Rolle's theorem. Then what do you want to do basically? See, we are given a derivative. We are given an expression, and we need to identify whose derivative is this. So this is one of the procedure to find whose derivative is this, and that too it is applicable only one type of equation, and that type is f dash plus g into f. This type of expression is given, then you can make it exact derivative. So it's a process to make it exact derivative of this particular expression. Acha, oh no, this can't. Okay. Now I got it. You are saying that you need to say you want to simplify it. No, you can't simplify it. If you have e raised to ln of something, then that is the property of log or property of exponent. So using that property, you are writing it fx. Okay, so in that case you could simplify it. But if it is e raised to x square, then you can't simplify it. If it is e raised to ln x square, you can't simplify it. If it is something else, you can't simplify it further. That was the property of log x. That's why you could write e raised to ln fx as fx. So if it comes out to be like that, then you can simplify it. But if it is like this, e raised to ln whole square, then you can't simplify it. You'll have to write this only. Now I got your point. Oh, you were stuck to this. You wanted to simplify this particular function. Huh? No, you can't simplify it further. Have you understood? No, नहीं कुछ नहीं होता. Okay, that's not कुछ. अब e raised to tan x if you are getting, then it will be tan x only, right? You can't simplify it. But if you're getting, if you get e raised to like ln of something, like ln of tan x, then you can write it tan x. Okay, then you can write it tan x. It's a property, simple property. So sometimes you'll get like this. Okay. Now you understood everything, huh? So I'm going to give you one. Shall I give you one last question? Okay. If f(x) is a differentiable function, if f(x) is a differentiable function and f of differentiable function for all x, okay? Differentiable means continuous also. F of 1 is equal to 2, f of 3 is equal to -1, f of 4 is equal to 0, f of 5 is equal to 2, f of 6 is equal to -2, and f of 7 is equal to 0 again. And okay, then find the minimum number of roots of f is a thrice differentiable function. Fx is given a thrice differentiable function. Minimum number of roots of this equation, huh? In 1 to 6, 1 to 7. Open or closed, same thing. This is our last question, okay? And LMVT will continue tomorrow. LMVT and Cauchy's theorem. 3. Let's see. Whose derivative is this, by the way? If I write h dash x is equal to this, f dash x into f double dash, right? This is your f. Now see. No, f dash x का square नहीं है. It's not f dash x square. It's f dash into f double dash. Are you understanding? Now there is no lag, right? There was a slight lag was there. You understood? It's a derivative of f dash into f double dash. Now see how many roots fx has. Because fx is a continuous function and some values are given. So if we try to plot this function, then f of 1 is given 2. F is here. Then f of 3 is given -1. So f of 3 is given -1. So f is here. Then f of 4 is given 0. So f of 4 is here. Then f of 5 is given 2. So f of 5 is 2 here. Then f of 6 is given -2. So f of 6 is -2 somewhere here. And f of 7 is given again 0. So 7 is 0. Huh? So if you roughly sketch fx function, then fx function should be like this. Huh? So it will cut the x-axis. It will meet the x-axis at least 1, 2, 3 and 4 times. At least 4. It might be more, but using the given information, we can say fx is equal to 0 for at least 4 values of x belonging to 1 to 7. Is that okay? क्यों? f के तो गलत बताए ना तुमने. f के 4 आएंगे. f will have 4 roots. Clearly we can see if f of 1 is positive and f of 3 is negative, तो बीच में एक बार क्रॉस करेगा ना ये x axis को. You have just taken 2 values, huh? 4 and which one? 7. Positive to negative हो रहा है, so it will cross the x axis between 1 and 3. It will cross the x axis between 1 and 3. It will again cross the x axis between 3 and 5. And it will again cross the x axis between 5 and 6. So fx has 4 solutions, 4 roots. Fx has 4 roots between 1 and 7. Then f dash, you can clearly see f dash will have 1, 2 and 3. Minimum 3, can you see? So as fx is equal to 0 has 4 roots in 1 to 7 closed, 1 to 7 closed, then f dash x is equal to 0 has at least 3 roots, right? In 1 to 7 open, and f double dash x is equal to 0 will have at least 2 roots in 1 to 7 using Rolle's theorem. So f dash into f double dash will have how many? 5. This will have minimum 5 roots. Huh? And because this has 5 roots, so we need to find the roots of h dash. So h dash will have 4 roots at least. Huh? You gave the right answer in the beginning. Huh? I don't know why, but ऐसे ही एडवांस में आते हैं. इनफैक्ट इससे भी ज़्यादा और बेटर ऐसे आ चुके हैं. एग्जैक्टली द सेम क्वेश्चन हैज़ कम इन एडवांस्ड. एग्जैक्टली द सेम. I mean, data might be different, f of 2, f of 3, but exactly same question was there in JEE Advanced. If you see past year questions on Rolle's theorem, you'll get this question. Are you understanding this question? Have you got it? Once you know the concept, then it will be easy. Once you know all the, I mean all the things, then it is not. See, there's no calculation at all, right? Everything is observation. Limits, में sometimes they give very easy question as well. Huh? So in overall calculus, they give very good questions. Few questions are doable, easily doable. Few are moderate, and some questions are really tough. So if you don't know, if you haven't done calculus of that level, then they will look difficult in exam, because they give a lot of questions in advance from calculus. Chalo then, okay, see you in next session. Pair of straight lines. Huh? I'll take that session around 7 o'clock. Okay, 7 or 7:30. G.N. Berman is a good book. I'll start that session around 7:30 or 7 maybe. Okay, after 3 hours at least. Yeah, 7:30 you can assume. Huh? A time might be given 6, but I'll give you 7:30, and 7:30 I'll start. चलो फिर, okay, all right.